Okay. Okay. Oh, wait, hold on. Okay. Good morning, everyone. For everyone who lives in Japan like me, good evening to everyone else. Ba 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 ba. Ba 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 ba. All right, so last time we left off, I was making some sprites for an eventual move to making a platformer, but rather than do 2 days of platformers in a row, and not to mention the fact that yesterday you did a sprite making with with another person, I went ahead and made some sprites offline for us to use today, and we're just going to jump straight into making a platformer. Ba 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 ba. So let's do it. Well, first let's do a warm up. We're going to be doing it in Wolf.js, which is a library that our company put together to help people transition from Scratch to JavaScript. So it tries to use Scratch vocabulary, like forever and such, to make the transition to using JavaScript a little easier. Let's just do a warm-up project for the first 4 minutes. Alright, I'm logged in. So this is the UI. Documentation and stuff. I hopefully won't need that, but I guess it could always happen. Alright, and this is our preview window. One thing I kind of don't like about the preview window is that it's always changing the sizes. Like if it squishes, which just makes it difficult to like really get a sense of what you're working with. But anyway, let's do a warm up. Let's do as a warm up, why don't we animate a sprite? That is going to be relevant. So let's upload an image. You can't see obviously, but I've got a file open dialog. Sorry, I've got allergies. They come and go in waves. And you're at like more or less the peak I'm almost certainly going to see is in the next while. Please forgive me. Okay. So I have a 5-frame coin sprite here. Oh, fine, I'll save my project. I already have one called Platformer. Do I really? I don't see one called Platformer. Is it really a unique key across everything? Okay, well, we'll call it Trek Platformer. Apparently, Wolf.js has a unique project key across all users and not just yourself. Alright. What was I doing? I was uploading pictures. Uploading sprites. Sprites the world over. Alright. So we got coin sprite 1, which did not appear, I don't think. Where is it? Where are you, my darling? I don't see it. Well, fine. I'll upload you again. Where? Why aren't you uploading? What's your beef? Okay, there's one. There's two. Now it's working all of a sudden. Okay. Three. One, two, three, four. And 5. Okay, so we have 5 coin sprites here. They go in order. So let's see if we can determine which one's first. I think it's this one. I think it's this one. So let's create that. I'm going to break out its properties here to be more legible by my JavaScript mind. Okay. X, just make sure this all works. Yep, then moved it over. Y, 50, width, 200, height, 200. Okay, wait, the exact ratio of these coins, hold on. I just need to check that off screen real quick. What is their supposed height and width? They are 19 by 19. What? Oh no, that's with some extras. They are 13 by 15. Okay. 13, 15, good times. Alright, 13 by 15, let's just make sure that our, let's just calculate what our proper ratio is here. So if our width is 200, 200 times 15 divided by 13, 231. Or 230 is fine too. That doesn't look right. Is there something wrong with that math? If the ratio is usually 13 to 15, isn't it? You flip it. Yeah, that should be right. Why does that not look right? Did I read the wrong value? $13 by 15. Why does it still look squashed? Weird. What's going on here? Why are you squashed? What if we just do width times 2 and height times 2? Well, first and foremost, it's anti-aliasing. Why is that number still so big, though? What is going on? Why is that the deep? Just a moment ago, it was on the screen all tiny like. Hold on. Okay, let's go with 3. Or 4 is fine. I actually typed a 4. But 4 is good. Okay. We'll do it like this just because I don't know what's going on with the ratio. Because it does not look right. I think like the actual image file is a square. It's a 19 by 19 pixels. But the actual pixelated area is 13 by 15. So when I gave them both the same number, it was squashed, which means it isn't using the 19 by 19, obviously. And when I gave it a 13 by 15 ratio, it's still squashed, so I have no idea what it's doing. So I'm just going to leave it like this. And okay, so we got our coin. We can give it a position, we can do the things. Now we need to animate it. Forever. Coin dot set image URL to another image URL. I'm gonna comment that out briefly. I'm gonna turn off auto run actually. Auto run, just so it's not jumping around all the time. Anyway, okay. Let's make an array var coin sprites becomes equal to Alright, now let's list them out. This will be number 1. Comma. There's number 2. Number 2, I believe, is this one. Why is that one a different length? I don't know why it's a different length. Number 3 is this one. Number 4 is this one. And lastly, number 5 is this one. Okay, and then one last step I really want to do. Actually, I think this is fine. The only thing I want to do is capitalize this. Coin sprites. Alright, so then here, instead of listing out the whole URL, we can say coin sprites 0. Okay, and then forever. Instead of ever, let's use every. 5 seconds. Coin.set image URL. I'm gonna give the coin an index property so we know which current sprite it's on. Actually, let's call it sprite index. just because it's possible we might want to use index something else later. And every second we coin dot sprite index plus plus, and we set the image URL to coin sprites of coin dot sprite index. Mama llama ding dong. So every second it increases. This is 0 here to a 1. Oh, we need to have it cycle back around. If coin dot sprite index is greater than or equal to 4? Oh, 5, yeah. Coin dot sprite index becomes equal to 0. So that'll make it wrap back around. Let's try it out, shall we? Which wait, this? Which one? Dot sprite index. Does this work? Undefined? I think that constructor is not kind. It's not very well set up. So we'll just put it here. We go. Oh, look at that. We got ourselves a little coin. All right, good. Now, I think our first step is how we're going to make this be reusable. We can just create a coin. Bum, 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 bum. Basically, we're just going to put this into a function. We will call it coin. We'll put all of this inside. Tap that out so it looks okay. And we're going to return the coin. We'll take an X and a Y actually. Is that all gonna work? I think so. I'm just gonna make it so I don't necessarily have to type in X and Y. Give it some default values. Okay, I think that all looks pretty good. Now let's try placing some. I want a coin at -200, 100. I want a coin at 300, 400. Let's try it out. Problem on line 8. Is the other one off screen? How wide is this? Yeah, there it is. Okay, cool. Got 2 coins. They're both working. Snazzy. Perfect. Alright, we can just throw out coins now. Alright, next up is our character sprites. Let's upload our character sprites. Alright, so let's see, I think we're mostly just going to need our idle. Is this idle? That's idle. Yeah, alright. And then, so this one is going to be a little bit different. Var care sprites. This one's going to be an object because I want to give them names. Idle. Right. Upload. And if we need, I'm just going to grab idle, left, right, and the 2 running sprites. If we need more, we can grab them. But for the moment, I think that's all we need. So go with right. Upload, please. There it is. I don't understand this upload thing. Puts things in weird, random places. Okay. We need right run 1. Yeah. Never tell the difference between run 1 and run 2. Right run 1. Then we need, oh, not period. We need right run 2. Because I've made 2 animation frames for running. Which I believe is this one. Oh god. Oh god. I can't. Alright, one ends in 5, one ends in 8. We want the one that ends in 5. Which is this one. And right run 2. And then our left sprites. Left. Where is it? There it is. This is left idle. Or just left, as I'm calling it. Then we need left run. So a lot of you might wonder why we have separate sprites for left and right when they're just mirror images. Well, A, they aren't mirror images. Sometimes our characters have, you know, hair that's, in this case, hair that's on down one shoulder but not the other. Or sometimes they'll have like a mechanical arm on one side, or they're right-handed so they hold a weapon on their right side. You know, it's not 100%, but also it's just inefficient. Much more inefficient to tell the computer to flip sprite every time it's rendered than it is to have it just render a different sprite. So it's actually a performance issue. What was I doing? All right, we're on left run 1. I believe is this one. So maintaining your sprites is an important part of making a game. Left run 1. Obviously these are very simple ones because I'm not really an artist, I'm just doing the things we've got to do. And left run 2. Where is it? Oh my gosh, like, okay, luckily that's still highlighted so I can tell it's this one. One thing that I don't like about WoofJS is that it anti-aliases on low resolution files. Like, if you don't know what anti-aliasing is, it means that it's averaging out the pixels. Since I gave it a really, really small pixelated pixel art file, it as I made it bigger, rather than keeping all of the hard edges on the the square pixelated edges, it averages it to try to make it look smoother, but it ends up just making it look like blurry. But anyway, we got our character sprites, so we can create a new sprite. So var image. Do I like keep losing my connection to chat? I've got like just 1.5 million left for the chat room messages. Alright, anyway. Var char is equal to image URL is char sprites dot idle we don't really need to specify anything else until we get to the point where we're making multiple levels. We won't need to add a lot of features to this constructor, so I think this is good enough for now. But we do need to add our every. Oh no, it's more complicated than that. We can't just add that. Hello! We need to double her size. Char dot width times equals 4 and char dot height times equals 4. You can see how she is kind of blurry, but she didn't look like that when she was shrunk down. And I can even show you the original file real quick, just to prove to you that these are in fact not as blurry as they appear. Sure, that works. But you can see they do have hard edges. It's just the way Chrome is choosing to render images in this particular in the WoofJS context. It's actually a big request of mine that they fix that. Anyway, we're gonna keep moving for now. Alright, so we have a character. Now we need to implement her controls. So on key press is how we do it here, right? Back on key press, on key press, on key press. Sensing? No, it's a mess. On key down. Okay. So on key down. If keys down includes left, Then we're going to model velocity and acceleration. So I'm going to say what do I want to do here? I was trying to think if we're going to do this by deltas or if not. I think we should avoid deltas. Try to keep this within the realm of what do you call it? WiFJS blocks. So we'll just write velocity x equals 0, and we'll just split it. Velocity y equals 0. So now we have a velocity property. Alright, and then when we push left, our velocity x minus equals some number. Let's go with like 3. And I actually don't want to use on key down. I want to use forever, because I want it to continue to accelerate for the length of time you have the key pressed down. Not only accelerate when I push the button. And that means like push versus hold are different. So just to prove this works, it doesn't. Why doesn't it work? I'm going to do just this will be for debugging purposes. I warned you I'd sneeze. Oh, I know why it's not going left. Okay. Because I never coded it to move based off of velocity. Okay. I'll finish coding this debug thing real quick just because it'll be useful later. New text is equal to in this case keys down. Y should be equal to like 50. X should go to like 200 or so. That should be fine. X plus equals velocity x y plus equals velocity y. Yeah, so this is just those two lines right there, models of velocity. So now we should be able to, accelerate off to the left. And you can see my little thingy, my thingy. This does not appear to be. Oh right, WiFJS is 0. Like 0 is in the center of the screen. But anyway, all right. So, next thing we want to do is cap our velocity. We'll also do our right velocity real quick. but we want to look up the math.absolute value function. It's just ABS. So then I'm going to put a comment here. I'm going to cap velocity, so they can't just accelerate off to infinite speed. So if char dot velocity, I can't read. Get out of my face. If the absolute value of char dot velocity x is greater than, I don't know, 10. These numbers can obviously change. In fact, let's start putting some configuration stuff up here. Var max velocity. I don't know why I'm adopting this not camel case system, but we're just gonna roll with it. Then we want to char dot velocity x is equal to max velocity x times sine of char dot velocity x. Is sine an actual function? Pow is not. Whatever, we can. I'll just write the sine function real quick. This is sine, not sine, just to confuse everyone. Number. So this returns number divided by absolute value of number. So if it's -5, it returns -5 divided by 5, which is -1. If it's +5, it returns 5 divided by 5, which is 1. Very simple function, just to get the sine of something. Alright, and then this needs to be repeated for y. Max velocity y. We don't even have jumping yet, but I'm sure this will become relevant in the near future. This should probably be higher. Alright, let's try this, see how it goes. What? It is. Yes, it is. Oh, okay. All right. Yeah. Very good. Okay. Now we need deceleration, and then we'll attach it to the animations. Char dot x times equals friction and char dot y times equals gravity. These are the two. Actually, never mind this one. do grounded times friction. How do we want to do this? So we're going to have a grounded variable, obviously, for whether we're on the ground. We will only want you to slow down if you're on the ground, because otherwise there's no reason to slow down. So grounded is going to be a true or false, which its truthy value is 1 and 0. Why don't we do minus equals grounded times the sine of char dot velocity x. So this will so if we're going left, then since this is negative, it's going to reverse it. It's going to add velocity, and it will only add velocity if we're grounded. Okay, I think that works. Friction becomes equal to 2. And actually, we're going to add this as a character property. Dot grounded becomes equal to true, since we do not have jumping at this point in time. Okay, let's try this. Something went wrong, so we ended up in a very strange place. We need the truthy value of this. You know what, there's an easier way to do this. Or a better way. Char dot, I know what's happening here. It's because we're trying to do sine operation of a 0. Oh. What is the correct behavior? Maybe it's maybe it's that. Now we aren't slowing down though. Why is that? Debug, please log this for me. It's going in the opposite direction. Weird. I swore it was right. Wait, what? Why isn't it slowing down? Oh, I'm okay. Hold on. This should be velocity x. And this should all be a line up. There we go. Okay. Looking good, looking good, looking good, looking good, looking good, looking good, looking good. Alright. So now we have basic movement. Let's do, should we do animation attachment or should we do jumping next? Let's do animation attachment. So we want the idle animation, the idle frame to be shown when we aren't moving, when our x velocity is 0. And we want the other animations to be playing at a rate proportional to our velocity otherwise. So I'm gonna, this will be, call this the physics loop. I'm gonna separate these into two different forever loops just to keep things organized. I'll call this drawing loop, or the animation loop. So, if char dot fill ABS, oh, I don't, not ABS, ABS, velocity x is greater than 0, or is equal to 0, I should say. Char dot set image URL, not whatever that is, to char sprites. Still idle. Why did it do this weird tabulation? Weird. Did I ever give a sprite index to? I did not. Char dot sprite index. Is that what I called it? Yes. Alright. If absolute value of, alright, we'll just do else. Grounded. We're going to play running animations. Char dot sprite index. We just want to reset it to sprite index 0 whenever we stop. Okay. How do I want to do this? So this is facing right. Then set image URL. The snippet that pops out isn't even correct. Like, it's not syntactically correct. What's it doing? Char sprites. Okay, so we have a right idle and a left idle. So actually, when we aren't moving, we don't want to go to idle. We want to go to right idle or left idle, depending on where we were. Okay. Char dot last velocity x. Comes equal 0. I assume we'll also need a last velocity y at some point. How do we want this to work? What we don't want it to do is, so when your character is walking, you're walking, right? And it's setting your last velocity equal to what is essentially your current walking speed. Then you stop and slow down. We want it to stay with your last velocity being the walking velocity, even though you're not moving, and not reset, go to 0, because now in the next frame you're still going at 0. So I think we actually need to track 2 back. Is that right? So we need like last and last. And then we only change last if current and last are different. Let's see if this works with a fraction of the complication. Call it pre-xv. Char dot velocity x. And then after all of these velocity changes, if char dot velocity x is not equal to pre-xv. Basically, we're tracking changed. be changed. Does it need to go here as well? I think it does need to go here if we add in a clause about it not being 10. Actually, no, I guess we do. No, we just do. Okay. Okay. We just do need it. This should not affect it, because this is just you slowing down. It has nothing to do with whether or not you've turned around. Because that should not be able to change your direction. I guess we'll do last velocity x we do need to track it. Alright, is this going to give us the behavior we want? Let's find out. Actually, let's do switch. The sign of char dot last velocity x. Case 1. That's not what I meant. Right. Break case 2. Oh, not case 2. Case -1. Left. And then default. Idle. Okay, so that should, I believe that'll work. Let's test it. That is laggy as hell. What? Why did we get left? Why are we getting right run frames when we do that? Or are we getting friction frames that are... Buzz, buzz. Ba, 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 ba. Sorry. Okay. So to keep this friction function here from accidentally jumping us over to the opposite side, like for example, if we're traveling at 1.5 pixels a second, friction is 2, so when we subtract it, we end up with negative 0.5 on the opposite side. So we just want to make sure that this friction variable here is always the friction value or the current velocity. So I'm going to break this out so it's a little easier to read. Okay, so char dot absolute value of char dot velocity x. If it's less than friction, then use that value. Oh. We could just use a minimum, right? There is no minimum or maximum function here. Whatever, we'll just... Oh my gosh. To keep it, like obviously using a minimum or maximum, a masked out minimum or masked out max here function would be the easiest way. But since that's apparently not in the WIF.js vocabulary, I'm going to go ahead and use a ternary. Ternaries aren't either, but they just represent if statements, so that I can still explain if else. Sorry. Okay. Then we want to use the absolute value instead of the friction value so that it goes to 0. Otherwise, friction. So that should keep it from jumping to the opposite side. Meanwhile, okay. Alright, let's see if we can do the right side animations real quick. Sprite index plus plus. We'll just do a switch. It's fine. Switch on char.sprite index. Alright. And then we just need to reset it back to 0 if it's over whatever. If char.sprint index is greater than 1, char.sprint index becomes equal to 0. Try this out. Okay, it's not alternating. That might just be lag. Oh my gosh, it is so laggy. So, like, look at that. It takes like 20 milliseconds to update. Oh. Can I log char.sprint index? Not a number. Oh, what the hell am I writing? It's not sprint. Sprint index? Sprite index. Sprite index. Sprite index. Okay, 0. Yeah, stay 0. I don't ever see it going to 1 though. Why is it never going to 1? See it ever going to 1. I just can't decide if that's because of lag or if there is actually a bug here. I don't see any bugs. There you are. Look at that. I mean, travels backward for half the screen before she turns around. Wait. Why is it only changing on key up? Key, what? It's not laggy, it's, I can change it. Like, as long as I hold it, as soon as I let go, it changes. What is... Why would that be the case? This literally doesn't even reference key up and key down. Yeah, that is distinctly non-zero, so I should not be inside of the first block here. Okay, let's I'm gonna create a variable called area. This is just debugging purposes. And while it's in this block, I'm going to say area becomes equal to 0. Or not there. And while it's in this block, I'm going to say area equals 1. Here I'm going to log area. I just want to know which block it's in while it's doing, what am I doing? Area. Okay, so we're in 1. We're in 0 right now. Where are we in 0? Look, we're in area 0. Oh, I know. It's because that's why. Okay. So, I can explain this. So, during the brief moment where I lift my finger off the right key and go to the left key, it sets my character sprite to facing right. And then I don't have a sprite for facing left until I let go. So I think this is just because I don't have the sprites I need. Let me put them in place, and let's see what we got. So this should be just an else. So I don't need if. Right. Right. So we just need left run. Left run 2. Alright, let's see if that. Alright, yeah, okay. Now we just gotta figure out why it's not going through both frames, which I believe is a visibility issue. Alright. Okay, so here's what we're gonna do. We're gonna make it so, instead of 0 to 1, we're gonna go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Essentially, we're going to increase the total number of frames this is going to use. 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm going to do the same for the other side. This is obviously very hacky, but until like we have a curriculum for showing off the idea of deltas, I think this is what we're going to go with. Okay, that completely reorged everything. What is going on here? What is... It's not going up or down. Why isn't it going up or down? There's very clearly a sprite index there. Why isn't it growing? Because I called it sprint index is why it is not growing. This problem is hilarious. Why did I spontaneously transition to reading about sprint indexes? Okay. Okay. Alright, alright. I don't know why it was so laggy at first. Not bad. I mean, I don't... There's a tiny frame gap at the very start. If you notice, like, I go back about a step before I change. I'm not sure what that is. But it also doesn't look bad. Like, there's an implied, like, rotational element there. In fact, if we can make it do an actual rotation, that would be cool. This looks good though. I'm just thinking about how we could possibly do the turnaround frame. Last velocity x. The sign of the last velocity x is different than the sign of the new velocity x. The problem with that is the 0 case. actually. Isn't this essentially the same thing as this? Also, there's no reason to do absolute value there. Let me try this. It totally worked. That's awesome. Look at that. Look at that. Look at that. Look at that. Oh my gosh. She turns. Okay, so it looks like the very first time it loads up a new image frame, it lags. That's why there's a lot of blinking right at first, then it's done with. Look at that. This is gorgeous. Look at her go. Woo, 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 woo. Yeah. 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 Okay. That looks great. I didn't really intend this when I was designing the characters, but they end up with, like, I gave them very football shaped heads from the side. It looks terrible, but also charming in a certain way. Because I was like, do we really want to give them square heads? You know, or not cube heads, like they're something out of Minecraft. It just didn't look right to me to make them so fat from the second plane. So they end up with these like football, these what do you call it? These like mint shape heads that originally were, you know, I only put this together in mind when they were just facing the camera. So I was like, okay, this looks good. They look like, you know, cute, chibi or whatever. They look like those Bratz dolls or whatever. Then it was like, okay, time to give them a side sprite. It's like, oh no. This is awesome. Okay. What time is it now? I think it is time to do jumping. Well, okay, we can't do jumping until we have collision. So we have to do collision first. Collision, huh? Collision. Collision. Alright. So collision. So let's alright. Care stuff, coin stuff. I guess let's put the collision stuff in between the coins and the characters. Just kind of keep things in a order of priority sort of order. Okay. So, first we need a sprite. What do we want to use? I don't actually have any floor sprites. I haven't made any of those yet. So let's just take a look and see what we got. I just need something that would look okay as a floor. We could use this foresty thing, but we would have to create an invisible collision object on top of it. Like, we'd use this as the background and create an invisible one. Maybe that's okay. That might be a good place to start. Or this Mario one would be fine too. Or this one. Flappy back. Tell you what, we'll go with this flappy back one. And then we'll create an invisible object. I really hate that it doesn't load everything up right at the start, and that I have to, you know, fight with it. Also, I could have sworn I told you to start with idle first. Yeah, I did. Anyway. Okay, so we'll use an invisible sprite for the collision. This one, put it up here. Okay, so var floor. Well, let's abstract this to create a collision box. Collision box takes an X and a Y. Okay, and we create a sprite, and we'll let it take an image URL, but it won't be required to use. So var sprite new image, and that'll take X, 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 Y, Y, and then URL will be choose the value of URL. And then use it, otherwise null. I guess we could take a width and a height as well. XY with height URL. Okay. Width, height. Okay. And we need var colliders. So a new array. Push sprite. Okay. And var floor becomes equal to return sprite. Collision box. What the hell is the code for getting the left edge? Window. Right, there was stuff that was appearing there. Screen. There we go. Min X. Min X. X. Oh, this is sorry, XY. And X, and then whatever that is, which is like max Y, max Y minus 200 or so. Then the width is max X minus min X. The height is, go with 15 pixels, and no URL. I'm going to temporarily give this a URL, just so I can see where it is. this work out of curiosity? Maxi. Okay, it does not like an empty URL. How do we want to split this? So we want it to produce a rectangle if it's not a URL, if it's like a color, for example. Here's what we'll do. Okay. All these exact same properties. Except no URL. Is that gonna run? It is. It gives it a default color of black, which is super annoying. Oh, we actually want min y. I keep forgetting that it's the other way around. Plus 200. That was pretty close, actually. Let's try 190. We'll say that the width is strangely low. This is not going off screen, is it? It is going off screen. Why is it going off screen? Is it the center of the rectangle? If I type 0 here, is it? It's the center of the rectangle? Oh, there's still something missing here, but it is clearly the center of the rectangle. What are these minus? What? Okay, there's some transformation of the grid problem here. I'm trying to get the width of the screen. You know, it doesn't matter. Let's just times 10. Just make it go off. There's something obviously wrong with how we're calculating these values. Okay. Why am I so small all of a sudden? Why am I so small? Why? I literally didn't change. What the hell? Why am I... Excuse me. What? Why did my sprite shrink? No, I can't change its size. We'll deal with it later. What is going on? Why are the coins randomly skipping frames? Look at that. Man, we are getting all sorts of performance issues. Oh look, I just, what is going on? Alright, we're gonna not worry too much about it. I think it's some kind of refresh. But I do need to know why my character is suddenly the size of a mouse. So if I change the coin size, the coins get bigger. But if I change the character size, nothing happens. Why would that be? Just gonna make sure. I'm gonna refresh this page. Excuse me. Oh my god. Oh my god. Oh my god, why does this button say saved? If it's not saved. Oh my god. Oh my god. Please no. Oh my god. Why? Why? Oh. Ah. No. Oh shit. Oh my god. All right, well. I got nothing. Maybe we'll do this project on web anyway, just because we're getting all sorts of performance issues. I mean, just look, there's one sprite on screen, and every 10 seconds or so it blinks out of existence. All right, well, next time. Oh. Peace. Oh my God. Oh. I knew it was behaving weirdly, I just didn't expect it to be related to saving. Like if I just type gibberish here, it changes to save. Something obviously bjorked. Sorry, I think we're probably just going to be done for the day. Like, there's not enough time to start over in web, because I don't really have that set up at the moment. So I'd have to, like, go off screen for 5-10 minutes anyway, just to get it all there. I don't want to rebuild it right here when we obviously have performance issues. I mean, we're even blinking. There's one sprite on screen, nothing else. And it's blinking out random frames. It's not like, this isn't a bug. We go through the entire cycle. It just randomly blinks out of existence. It wasn't doing this earlier, was it? I feel like when we first sat down, at the beginning of the hour, it was perfectly fine. Is it possible I hit some sort of bottleneck? I don't think so. Alright, well, I'll tell you what, here's what we do. We've got, some odd 15-20 minutes left. Why don't I just maybe show a programming game that I like to work on. Sure. Let's see, what should I show you guys? I will show you this. Get it booted up. Oops. Not Steam. Where is it? There it is. Okay. Alright. This is called Nimbotus. I'll just spend a few minutes here just to show you what this is. It's a programming game. I'll just, yeah. One second, let me just adjust volume settings. Okay. So, none of this matters. I'm just going to kind of show you what we're doing here. Okay, so this is our drone core. And we attach parts to it, including like logical parts like you know, AND gates and stuff to accomplish a particular task. In this case, we're trying to design a robot that can drill into a planet and collect a bunch of eggs while avoiding a snake monster thing. So, just as sort of like a quick sort of demo of what we can do, I'm going to attach some thrusters, rotate them, boop 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 boop. And that yellow dot is the center of gravity. We'll do something like this. And I'm playing on a mode where I can't, once the mission starts, I cannot push any buttons, so I have to program the entire AI of the thing all on its own. But normally you'd be able to control, like you'd say push W to go up. But I can't do that, so here's what I'm going to do. I'm going to go to sensors, I'm going to attach an altimeter. The altimeter is going to detect when I am at around 72% of the planet's radius. This includes its atmosphere, so this is actually above ground. With 2% altitude. When I am below this, I'm going to create a tag called thrust, and then this one's wrong. And when that tag is activated, I'm going to activate these. Just kind of show you how this works. We can. Oh, I need gasoline. Hold on. Some fuel. Oh, one. So yeah, I am below that. So then it stops as soon as I reach that point. If I turn some gravity on, see that as soon as I reach that particular point, I come back up. Simple enough. I'm going to lower the altimeter just so you guys can see what's on the surface, maybe around 40. We're going to fall because, oh, okay. This is all still too high. What is 0? Let's just see where 0 is. And 0 is too far. Alright, let's go with 10. I just want to be able to see the ground so we can discuss it in context. Okay. And when this usually ends up becoming necessary when I am down thrust. When I am above that elevation, I want to down thrust. Because a lot of planets have really low gravity and it's very easy to just fly off into space. Alright, these are going to be stabilizers. I'm also going to add a couple more engines here. This one on the right isn't going to do anything. This one on the left is going to be firing constantly. This is just a activate flag, so we can say like, go right, which doesn't mean anything, it's just text, and then as long as go right is activated, this rocket will fire. So this is just like a true flag, just always set to true. This one I just want to turn it off, so you can show you what's going to happen here. This is going to crash as almost certainly. Yeah. And we're actually going back up into space, although I'm sure we're going to do a full circle. Whoa. Oh, and then our altitude thrusters kicked in. Pretty chaotic, but it kind of works. All right, but anyway. All right, now I'm going to add a new sensor, a directional sensor. I can tell this sensor, first off, tolerance is 2, huh? That I want it to detect where the source of gravity is, like where the center of gravity of the planet is in this case. And it'll tell me if it's to my right or to my left of this sensor. So if it's to the, let me hook these up. So this causes my ship to rotate right, and this causes my ship to rotate left. Ba, 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 ba. So if the center of gravity is on my right, we want our rotate right thruster to fire. Right? And if it's on the left, we want our rotate, or our left thruster to fire. See how that works? These will be stabilizers to keep us straight. Yep, look at that. Look at. Then the down thrust deactivates, and our up thrusters kind of peek in and out. Look at that. We're orbiting a planet. We made orbit, everyone. This is a test planet, by the way. This is not the actual mission. Remember, our goal is to drill into the planet and collect eggs. But now we have an orbiting ship. Now we need to design drills or something like that. What should we do? Which side of approach should we do? I'll do, let's see, we got under 10 minutes. Okay, I could do something funny with the factory block, which lets me produce smaller robots that I can also program. But instead, we'll just do something weapon oriented. Maybe dynamite? Or a sniper laser. Let's do this laser instead. I've just got some custom designed lasers here. I think this one will be good. Alright, I'm gonna move this up, and I need to add a battery pack. Pretty big one, actually. Just see what this. Oh, I didn't tell it to shoot. Give these a fixed control, because I will not be able to control them in the actual mission. Just because we already have a button here that makes us go right, I'm just going to turn that on. I'm going to have these also turn on the go right flag. Okay, so I believe this will work for our in sort of a basic sort of way. This should start cutting into the planet. We are losing battery power though. If you see the blue box, this is not going to be able to be sustained. And also, as we get into the planet, we want to get further. We want to shrink over time, or go into it over time. So let's change our structure a little here. Maybe put these over here. Move this down. Add some structural elements, I think. Build off of this. First, we want more battery power. Move this here, copy paste it to something over here that we don't yet have, but we'll probably will. Let's just add it now. Let's make it another fuel pod. Attach this to here. Okay, so now we have more power, and we want it to shrink over time. So, how we do this is we need to build multiple altimeters all set to different settings and detach them over time, which I actually don't think we have time for. So why don't we just test this and see how it goes, and that'll be how we end. Is there anything else we want to do? That could be fun. Let's just try it. Okay, launch. Oh, this planet. Oh, don't hit the container. Okay, get over it. You got this. Ah, yes. All right, we're good. Oh, okay. The altitude on this planet is very different. Okay, we need to be higher. Hold on. We also still didn't have enough power, so we'll make a quick edit. More power. Hold on. Just need to make this orthogonal so I can place it correctly. Okay. And make a quick adjustment to the altimeter to be around 70, I know is... Actually, let's go with 50. Alright. And then we'll watch this, and this will be how we finish off. Hello! We're heavier now. You can get over it. This container is super annoying. Okay, we're good. We're too high. And we're dead. Yeah, we have no defensive structures for defending us. This is the drill orbiter. Yeah, we'll have to try harder next time. They destroyed our engines. No. Yeah, this is a cool game. You have to find a way to accomplish the task. Obviously, we failed. Real quick, I will just show you one that I believe does succeed at this, called the orbital siege. Yeah, orbital siege. So this is a resource collector. It's for mining. Don't worry about that. So this is actually a multi-part ship. These are not connected. They're just having problems. This is a combat block, which this is constantly producing them. All right, they detach. This is a high altitude orbiter. This is a low altitude orbiter. This is building low altitude orbiters that you can see. It's producing them. And then these are producing these combat blocks. Which fight and drill. They burrow their way into the core of the planet and collect anything they find. Unfortunately, we won't be able to really watch them because I have them set up to only bring the camera to them if they find something. So that'll take a while. But yeah, cool. Alright, thank you all for watching. Sorry about the problems with losing our entire game. I'll see you all next time. Bye-bye.